Hello friends, welcome to my YouTube channel. I am Ravi Singh and I am a research scholar of integrated manufacturing. Today I am going to show you easiest way to do FEM dynamic simulation on Abacus. This is my first YouTube video, so please don't forget to like and subscribe to my channel. Now let's get started. So now this is Abacus interface and we are going to perform our dynamic simulation on XSplit model. So now we need a workpiece first, so we'll name this as a job and let's say I want the workpiece size to be to 10. So now let's make a rectangle workpiece. It's up to you, you can design any way you want. Now give some standard value to it, like suppose I want to make it as a 5 mm length and 5 mm this. Once it is done, let's do done. I can give a height as a 4 mm. So this is our rectangle workpiece. So once you design your workpiece, now you need your cutting tool. So I have designed my cutting tool on CATIA. I will import that. So this is a ball and milling tool. It is also it is mostly used in precision manufacturing, like aerospace component and some like biomedical implant, some instrument. So you can see the bottom of this tool is completely like a ball in shape. So today we'll study like what influence actually does it produce during manufacturing. So we'll study the force, temperature, stress, strain during manufacturing with this tool. So once we have workpiece and cutting tool, now what we need is we need to assign material to this. So now we go to property, we want to apply property to this one. So material library. So in Abacus you actually don't have material library, you need to create by yourself. You need to add their materials. So I have added here carbide. So you can add like according to your requirement. Like suppose if you want some another tool, some another material, you just go to create here, like some you can name is at aluminum or anything you want, platinum, titanium, whatever you want, you name it, give the description, and then you can assign a density to your material and elasticity, plasticity, damage, whatever you want. According to your requirement you can name it and you can assign the property to your tool. So but however in my case I'm going to use it as a carbide tool. So it is very important to assign material to your workpiece. So once we are done with that, I will name it as a tool, and of course it will be carbide tool. I'll select this one, and it's once I do this, done. Now you see our tool has a material property of carbide. So this is now carbide tool. All we need is now we need to assign material to our workpiece. So for our workpiece I have magnesium. You can add any type of workpiece. Again the same process, you go here, create your workpiece, assign the material. I have done it like that. You can see what parameter I have kept here, like conductivity, JC damage, damage evaluation, density, elasticity, everything, whatever you need, specific heat, whatever, how you want to describe your material, you can find that in some books or in internet or in some paper, journal paper, and then you try to assign it. I have also published paper related with this one, so if you want, I can also give a link to that, my paper, you can find there about that. So now we will just keep this as a job name. So magnesium, I want to assign it, select it, say done. Now just select it is job magnesium. Okay, done. So once you apply material property to the workpiece and tool, now we go to the assembly section. We go to assembly, select the instance, and now we are done. You see the position of the tool and workpiece are at different place, so we need this tool to be the right position from where you want to machine. So I'll select this bottom of this one, select point over here, and then I want this tool to be exactly over this point. So now keep done. Again, I want this tool to be 0.5 mm below the workpiece, so that it can remove the 0.5 mm workpiece. So I'll go to this end again. Okay, now it is done. You can see it has, I'm okay with this distance. So my tool will start from this position and it will go up to here, and it will remove 0.5 mm material from this workpiece, and then we will study what the temperature, what the force, and what stress strain this tool produce on the surface during the manufacturing process. So now after this we go to meshing section. So for mesh section you need first go to part. Okay, so as you know, for mesh size it have to be very fine, but the size of our this workpiece is little larger, so it will take a long time, probably 6 or 7 hours if I go with this one. So I want to divide this workpiece into two parts and then assign the two different type of mesh, so the time duration would be less. I'll show you how you can do that. So first you go to part again, divide this into two parts. To two part, press done. Now I want to divide this into two part along this direction. Okay, now partition is created. You can see now it is divided into two part, right? Now we can go to again mesh section. So for this one, now we'll seed this one. Okay, 0.5 is fine. I'm okay with this. So you see the seed is produced over here. Now seed on edge. For this one, I will select like where I want to apply. finest grain on the top, because our workpiece will work here, so I want a finest mesh over here, and at the bottom they don't have any impact, so we don't care about this one. We can keep a little larger mesh for this one. Okay, done. By size is okay, you can give it 0.1. This is okay. You see the fine mesh is produced over here. Now I can select this one. Okay, which type of mesh we want? We want hexa is okay, hexa is fine because it is a plane surface, so hexa mesh is fine. Here this is one important. You have to select split. You can also select a standard according to your requirement, but here bottom it should be coupled temperature displacement, and then we need reduction, reduce. Once we are done, we press OK, and then we apply mesh. You see now on the top the mesh size is finer, whereas in the bottom the size is quite large. But all we want to study is on this part, how the tool, what the influence of the cutting tool on the surface. The tool is only going to mesh in 0.05. So now we want to mesh our tool. So this is our tool. First we go here. We want tetra mesh over here. So fine, we applied. Now we will set this one. So I'll show you. This one we can set it as 0.3 will be fine, I guess. Apply. Okay, 0.3 is fine, because if we make it more fine, it will take a long time. So that's why. Now I see. So once the mesh is done, we go to the step section. Here we'll describe. Let's create. You see initial is already created, so we'll create another step 1. So for this one I will select dynamic temperature split. We'll say continue. So you need to give a time period, what time period this tool will take to reach up to here. So in my case it has 4 blade, and I'm going to rotate it at 3000 rpm. So it will take actually 0.0033 second to reach this tool up to here. So after this one, which will do mass scaling. Okay, you need to put here what will be the scale factor. In my case I'll keep 500. You can keep according to your desire. It does not have any limit. You can even make it for 50, 100, 200. I kept it 500, and then it is done. Okay, so output manager now. So we'll go edit. So interval, I want to keep 500 over here, and you can even keep 100. It's up to you, like how you want to keep that things. So we want to measure temperature, so this is okay. And for stress strain we want this one. Whether anything is missing here? No, stress strain is already here. Velocity is here. Temperature, yeah, for temperature this is okay. And now we're done. So this part is done now. So in the interaction section, first we want to make a reference point over here. So let's find a midpoint for this one tool. This is our midpoint. Now we need a reference point over here, so we go here. This is our reference point. So now we have to create a constant. This is a rigid body, so rigid body, and a reference point. This will be our reference point. So once it is done, we go to view and then assembly display option. Here we go to instant, and first we can make a silence, like now it is hidden over here. Now go to tool. So this is our workpiece, create, and just name it as a job node, continue. When it is done, select this, do this, done. Then again you can hide this one. You see now it appears like this. Again go to tool, select surface, create, let me make it like a tool. Okay, select it, done. Now let's bring it on. So after this, now let's create interaction, contact. So what we need is now tangential behavior, friction coefficient I will give it 3, and normal behavior is fine. Thermal heat generation, you can specify it, but I will keep it as default. This is done. Okay, do we need anything else? Heat generation, no, is okay. After this, placement. Now let's go here. We want general contact, surface to surface contact. Okay, now continue. Once it is done, you see surface is here, you just click here, tool surface, continue. We select here node region, select here, continue. Now you can see this is kinetic contact method, but we need planetary. And then everything looks fine to me. Okay, now it is done. Now you see it became like this. So now it is done. We go to load section now. Load. So now, initially we need initial one. We select initial, symmetric, and then continue. Okay, so this continue, select this place. You see now we want to lock this base, so we make it 0, everything is 0. So now it will not move from its position, only the tool will move. So our another, we select it step 1. Now we want velocity and angular velocity. There should be velocity as well as the rotation. So we select this one on the reference point. So we press done. So now you can select all of them as like this. Now our velocity along the x direction, it will be 1200. The feed will be 1200 for 4 blade at 3000 rpm. So this is minus 3000 rpm. So once you do it, you see the direction it is showing. Our tool will rotate like this. Now we are in job section. We will click here, create a job. Since I have not applied here vibration amplitude, I will name it as a traditional milling. Okay, traditional milling. For ultrasonic milling or advanced milling, I will show you after, maybe in another video with another tool. So it will be more comparison. You can do comparison how they are different from each other. Okay, now we go to memory. Okay, you can check and like use multiple processor. So it depends on your processor. If you have a higher number of processor, you can add here. So in my laptop I have only two, so I will just add two, and then you can press OK. Once it is done, you just go to data check. You can check your data over here. If there is something error in our model or in design, we can check over here. So it is running here, check is running. So now you see check completed, and here also we can see check completed successfully. Now we can submit for analysis. Press here submit. Okay, now it will take at least 7 to 8 hours to complete this simulation. After that we will see the result. So now we have completed our simulation, and this is what we got. This is our bone masses stress, and um, analyzing the data about force, temperature. I will show you how to analyze those data, but this video I think it is quite long, so I will make another video for that. So this much for today. Thank you for watching, and please don't forget to like and subscribe my channel. I wish you all can be happy every day. Bye bye.